Hello everyone, welcome to Lighting the Art. Today I'm going to talk about Upper Palaeolithic lamps in regards to cave art viewing and production. Please excuse if my voice sounds off because I've got tonsillitis. One of the main practical issues faced when creating art in complete darkness, such as the deep recesses of a cave many hundreds of metres underground where sun and moonlight do not reach, is how best to artificially light that environment. This is not as simple as bringing firelight inside. The materials used must provide a suitable level of light that illuminates a space well enough to work by, as well as having a good working time where it does not need constant maintenance to stay lit. Thus, lamps are vital as a mobile source of light which can be moved in space. There is some question as to the varied function of lamp wicks and their makeup. However, by evaluating the use of plants and animals in Upper Palaeolithic Europe, a feasible experimental project has been conducted to examine the viability of different wicks and fat fuels and their properties of illumination and beyond. The simultaneous existence of various lamps, from form to degree of fashion, suggests differing needs. Later in the presentation, we'll see how different levels of light are achieved depending on material. Many previous studies concluded lamplight can produce only a feeble and weak light. However, such studies have either not been based on experimental research or have lacked accuracy in the lighting they've chosen to simulate. There are current misunderstandings in the literature that do not effectively capture the capacity and use of Upper Palaeolithic lamps and how they can help us understand more about Upper Palaeolithic art. Such views demonstrate a problem of not recognising the potentially explicit association between mobile lamps and cave art. The experimental project involved recreating similar lamps as those found at Lascaux Cave and testing their light levels. To begin, the wick materials chosen for the experiments were based on indirect plant use evidence, such as those known to be present in the areas surrounding lamp deposits and those known from discovered fire-making kits. 2 animal fats were chosen to compare fuel properties based on lipid analysis that found traces of bovidae and suidae fat, so beef and pork lard will be used as fuel in the lamps, with each plant wick tested in both. The wicks were largely chosen based on a previous pilot study of mine whereby viable plants were highlighted for their porous properties or those which can become porous through manipulation, which allows capillary action where fat can be drawn up from the bowl to the tip, providing constant fuel to keep it lit. The wicks were made by rolling out the material and securing with a thin flax fibre, and the fungi was cut into strips of similar length and thickness. 14 wicks were made, so each could be replicated in each fat. 14 bowls were moulded out of air-drying clay as proxy lamps. Each fat and wick combination was lit in a completely dark room and measured with a lux meter for 15 minutes, with readings taken regularly to construct flame behaviour and illumination over time. The light from each wick-fat combination varied significantly, with some bright but unstable, some offering low but consistent levels of light, some which produced flames but were not high enough to register on the lux meter, and some providing significant levels of illumination. It's likely that whichever wicks and fats were chosen, it was a technological choice based on the specific properties of the materials, based on what the lamp was needed for. Different lux readings and different flame behaviour can be generated by altering materials. The pork lard produced overall brighter levels of lux across all the wicks, but the lard melted and was used up quicker, while the beef lard melted slower and uptake was slower, suggesting it may be more suited to more prolonged use of lamps, perhaps for navigational points. Once the varying light properties and behaviours were assessed from the compiled data and graphs, the wick-fat combinations which yielded the brightest results were chosen to be reconstructed in 3D. In the software Blender, a cave environment was constructed, based on the app's chamber for some real-world applicability, using the same dimensions. Due to copyright, please Google if you want to see what the app looks like. A lamp point was placed in the cave, 10 centimetres away from the back wall, with a camera placed 6 metres away and 1.5 metres high. The scene was run 8 times, each time the lux of the lamp point changed to reflect the experiment results. This provides a visualisation of how one lamp can realistically light and interact with a space. A small image was mapped onto the back of the simulated cave to make comparison between scenes easier. Each scene represents the top illumination potential for that wick, as the highest lux reading was used to visualise the maximum brightness that is plausible from one lamp. The wicks presented in Blender are moss, cattail, birch polypore fungus and hoof fungus, as they produce the 8 highest lux levels during the experiment, which has been converted to watts. There are vast differences between scenes in how well the image of the cave wall is illuminated, demonstrating how different wicks can produce alternating levels of light. This is the maximum lighting possible from a single lamp, but higher levels could be achieved by using multiple lamps and by moving them around a site to illuminate specific areas more brightly. As we go through the slides, certain lamps stand out, with the highest readings coming from the hoof fungus wick and the birch polypore fungus wick, which points of the cave are illuminated even from 6 metres away. This first slide is the cattail wick in beef fat, the cattail in pork fat, moss in beef fat, moss in pork fat. Now, with much higher readings, we have the hoof fungus wick in beef fat, the hoof fungus in pork fat, which is the brightest scene at a whopping 18.65 watts, the birch polypore fungus in beef fat, and finally the birch polypore fungus in pork fat. Assessment of the illumination levels, which may have been achieved inside cave art sites, can help to answer questions about the art, such as audience, working conditions, technological choices, communication, and the relationships between the rock and the viewer. The physical context of the art requires just as much examination when trying to establish purpose, including the lighting conditions. Simply, what light source is chosen to illuminate a space has an impact on how the images are observed. Even the placement of light in a space can affect the art, as it affects the legibility of motifs and symbols and how well they can be recognised. Light consideration is crucial to understand reception. This is demonstrated in the Blender scenes. Under some lamps, the wavy lines are clearly visible, while in other more dimly lit scenes, they are blurred and hard to distinguish. The cave space here is not a perfect reconstruction, with the dimensions and structure of the walls merely used as a base, with the program Blender chosen as its open source and suitable for the amateur 3D modeler, whilst offering realism for its light reflection processing. It's hoped that the simple simulation presented here can provide a basis for further study, or as an example of how to correctly input experimental data to 3D models, where direct evidence from a site falls short. An integrated approach must be taken to encompass archaeological, spatial, and artistic aspects of a cave art site. Lamps are a vitally important consideration when discussing the viewing, production, and context of cave art. Thus, it is essential to understand the power of such light through experimental practices. It is both the association between lamps and art sites and the properties of individual wicks that suggest a use for lamps specifically for art, viewing, and creating. The different properties of light and its potential manipulation, as demonstrated here, also could lend credence to such theories of cave art as shamanism and cinematic experience. Thank you for listening. I hope I've managed to convey my research in these few minutes. Please feel free to send me an email for more in-depth discussion or save any questions for the Q&A.